Here's this question. Called, this question basically, the idea is you have a bunch of number, a bunch of string, and have limited size. This is 6, so the length is 6, and all the question can be any number. So try to ask how many pair we have. When we do brute force, we will say how many n, right? N is 550k, so basically we have the first one compared with the rest one 3 times, and this one compared with 2 times, and this one compared with 1 time, so basically it's n squared. Obviously n squared is not working, so this is too big, n squared not working. But very special, m is 6, so m is 6 usually, yeah, experienced people will be like suddenly jumping to the called bitmask. So bitmask. So sometimes the number guiding you to how to solve this problem. The bitmask, the idea is so still we need to compare one by one. So absolutely, if you don't compare, you don't know which one is correct. This must be compare everything. But when you do compare, his idea is, what about we pre-compare everything? Then next time I'm coming to this row, I just to get the answer here. Just get the answer. So here I get the answer. So basically this one only 6. So use bitmask only 64. And we have 64 times 64 will be very small, and this is the idea. So let's go here. Okay. This is 2 sample. One is A, B question. This one is second sample. So in the beginning, we process this number. This number we turn to bitmask. Bitmask we can say letter. If letter will be turned to 1. So this is 1, and if it's a question mark, we turn to 0. So with the bitmask, I have this one. For this one, we can say, okay, how about we just pre-build everybody, right? So this bitmask, right? So I will have so all this 6, the pattern is come from 0 0 0 0 0 to 1 1 1 1. So like this, right? So this is 64. So you, no matter what, you gotta compare that one. So what way we just pre-build this one? So here is my so when we do here, we just remember the answer, right? So this one come to here, we turn to here, this number, we turn to bitmask, we build a bitmask, a 2D bitmask here. So this is 64, this row is 64, column is 64. So now we have this bitmask. This bitmask say come here. Then we compare all of them. So we'll do one by one, one by one, right? Let's say we do this one. 1 0 1 0, this one here. That's 1 0 1 0 here. Let's do 1 0 1 0 here. What do we do here? When we do the pre-operating, it will be coming, when you end this one, gonna be 1. So then this is 1, we go to the original value and say, hey, this one, when you do operating this one, only left number will be 8, right? Then in this cell, we have a hash map. We say, okay, A, we have A, the result we have A, then count 1. So it's here we have A of 1. Next time we have similar, like a similar pattern. Let's say, for example, A, C, question, D, question, right? This pattern is exactly same as 1 1 0 1 0 1. The same pattern and do the same operating, and we do the A. So we got A, this A will be so increase. Right now it's 1, right now it's just push to 2. Okay? So basically after we build this one, now we come to here. So we say here, if we compare all the pattern, what should we do, right? Because we already built all the answer sheets. So now we can compare. So if we do operating that guy, right? So if we operating this guy, we got 1, right? So now we easily say, okay, if we find the one, and then I find it's 1. What am I got? I got A, right? So I got it here. I'm looking for here. Say, okay, if I if I compare with this pattern, I will find that row. This is the row I try to find. I will find this row, right? If I compare with row, I will get answer 100. So this one already pre-built. He do the 100. What his answer got? He got 8. How many 8 he have? He have 2. So I will match 2 row. So my answer will be increased 2. Just like that. So keep going, going, going. That's the idea, right? So let's read the code. So in the beginning, we just previewed. This is the 64 hash map. Inside hash map, we just build like a dictionary. So in the beginning, we just initial. This is for Java only. That one is Java only. So in the beginning, so here we read a map. Okay, with row by row. We do the, in the beginning, we say, okay, we read that map. We read this one. Now we convert to the bitmask, right? So we get a mask. Mask is like, if you hit this one, we do nothing. If we don't hit this one, we turn to 1. So every digit, we just build 1. So just after finish, we have the mask. This mask is similar like this one, kind of a reverse, because we treat this one as 0 and this one to the 5, and after when you see the debug, when you see the data, we'll see reverse 0 1 0 0 1 1. But doesn't matter, reverse and first, all the same. Okay. Now this part is checking any answer math. So like right now we see we're looking for this code. This code is we pre-join all the possibility, right? So when here we say, okay, this is all possibility. This is 0 to m. This is the how many we have. M is 6, so 64, and then we're looping, right? We'll discuss this one later. So, and this one, basically we have, oh, when we do the join here, we mask this one. And if we hit that one, with the result is, if this is the result, this is my final result, right? If we're using that result, right? Remember this mask 2 is the when row 1 compare with row 2, the result is, if my result is this one, so if my result is 1, I go looking for my digit. So my digit is A or B or C, and then I hash it. So I build this one. I build this one. So if I like this, for example here, if my result is A, like this one, I pre-build this one. If my result is A, then I push here, this A. My result is A, right? Push A. Then you gotta keep counter. This is a counter. So we get this one, push one. This is standard code. Okay. Then after the next time when the new row coming here, okay, new row coming here with this one is the order mask, right? Order mask, we do the bit mask. So this one is mean, for this one, we gotta pre-build all the possibility, okay? Let's say I build it for this possibility, right? Let's say for build this possibility, I got 1. If I build this possibility, I got, this is my current possibility. This possibility, I get a hash, right? Then I say here, oh, I using this one, so I got answer. This is my answer, and then this possibility, what is my hash? The increase one. Okay? So basically keep counting, counting, counting. This is a brilliant idea, so we got the answer. So finally we cut it here. This one is final optimize, this one, because if we comment, this one still working. But the final sample we got TLE because there's a lot of unnecessary operating here. It create a lot of unnecessary operating here. So this is idea is the mask, like if a mask. The idea pretty weird. So this idea is like If you have number here like a 1 0 0 1 0, right? If anything I end this number, anything like say x, if anything I end this one, I won't be like only this two will be taken care, right? So only this one will be taken because this zero all gone. So the answer will be left only one and a one. This one will be matter. Okay. We add this one. The answer, what answer we have, right? This one in between. It's all gone, right? Only this one will be matter. So one and this one will be matter. So here, yeah. So this two in this, that means this digit, this digit, this digit, this digit shouldn't have any value. It's always zero. Only this two digit. When we do something, we could be like 0 1 0 1, right? Only this two digit can, because when we order any number, this is zero already. So when you end this one all gone. So here is nothing. Always should be zero. Only this two digit should be matter. This two digit could be 0 and 1, 0 and 1. But funny enough, so when you use this number all back, is always same as this number, right? Always same as number. This is another skill. You can say, okay, if my answer, final answer, if my final answer enjoying all this one is not to my mask. If not to my mask, what that mean? If not to my mask, totally not match this one. If you, when you final answer here, you all this one, you must be this number because we just proved that. So if not this number, we don't do that. So last that one was solved. This one will eliminate so many possibilities, right? Let's say, for example, for here, this one is like 16, right? This is 16. This is 16. This is 2, right? But this number is 18. This is 18. If we do the operator, so we do 64 operator, right? But if we just like eliminate that one, we say, okay, oh, only this number matters. So what do? We only have two number. See, this one only have two number. Only have 0 1 4 number cross each other. It should have 4 number. So when we do the looping, when we looping for this column here, we only need a looping 4 number, not 64. This skill is very important. So basically, if you put this back, it will find out if you put a large number, it will be TLE, right? But this one solved, you see how many times solved, right? So only the 1 1 1 1 1 1 will be the full number, right? The rest one will be like less number, so it will be like a small amount of calculation. Okay. So we solve this problem. This is called bitmask.